So we'll be talking about surviving the worst, that's disaster recovery, OpenStack. This is a joint talk by myself, I'm Ronen and from IBM Research, and Ayal from Red Hat. And this is a project, there's words for that. So we'll be talking about what is disaster recovery, trying to bring a little trailer, what is up next, and the idea is to bring something into the next release of OpenStack and beyond that will bring tools for handling disasters into the infrastructure of OpenStack. So we will have processes and a framework within OpenStack Cloud, so an end user can enjoy tools that can help him recover from disasters. And one specific component we're discussing today is volume replication. That's going to be in the Ayal release. There's places up front. There's sits on the first row. You're invited. I'm not biting. I'm gonna leave that to you. Then it seems that hiring to do work for free on OpenStack is popular today. So I'm gonna give a beer to anyone who wants to do that. So a bit of history. So actually, following the last meetup that were in, I think, March, IBM Research and Red Hat got together talking about disaster recovery, and what came out of that conversations, wasn't a single one, is work toward OpenStack disaster recovery initiative. And that's the idea to create a framework within OpenStack and enablement tools and API that will allow end users to have protocols and a way to recover following a disaster without the user having to build everything to make it work. So this is going to be part of the infrastructure that the end user can enjoy. And a few things that we have done so far. One of them is have 3 sessions in Hong Kong in the Ayal Summit. There was a breakout session in the user part of the conference, the summit. There was a disaster recovery session with the full house attendance given by Michael Factor. There was, in the design part of the house, there was a design session on continuous volume replication, the ability for the storage component in OpenStack Cinder to be able to do volume replication or volume mirroring between storage systems. And there was an unconference session led by Avishai and Ayal, focusing on the work of having disaster recovery framework within OpenStack and how should that be done. So just a definition, what is disaster recovery? So taking the words of Wikipedia, it's the process, policies, and procedures for recovery of technology infrastructure after a natural or human-induced disaster. So from that, what implies is that we need a geographical distance to recover from a disaster. And I think that's one of the main differences between disaster recovery and the other end of that is fault tolerance or high availability. So you could have high availability in a single site, in a single data center, but to recover from a disaster, flooding, hurricanes, although they're not around here, that's a bit harder with just one single data center. So the other component that you need is the IT infrastructure to survive the disaster. So that will be typically servers, storage network, software, and configuration. Just to start with servers, so what is disaster recovery in the cloud? So we don't really mean, having to move the servers or the physical infrastructure or the cloud infrastructure itself. In the cloud, we want to protect the workload that is running. So what we'll be actually protecting is the virtual machines, the information around the virtual machine, the cloud metadata, and move that to another location. So server in the cloud would actually mean virtual machines or instances. Storage, that's the piece that I already mentioned, that tools for the storage, the persistent storage component of OpenStack for Cinder to have volume replication, the ability to have your data not in a single place, but in more than a single place. Networking, the ability to move both your external connectivity and internal connectivity from one cloud to another cloud. Configuration is all about the metadata in OpenStack, that's the flavors, the definition that you have in U-turn, and all what is needed to redeploy your workload in another cloud. And the software, what you have running, and if you need to configure that in the other cloud. So I mentioned a couple of pieces. For storage, there's the OpenStack volume replication, configuration, and software could be done using tools like Heat that do orchestration in OpenStack. So these are the tools that you can use. So just to follow the last part, you need the processes, policies, and procedures for recovery. So there's always the good path. You need to plan. You need to copy your data in advance. That's a very important step. And you need to do testing, because every administrator knows that backup is extremely important, but the fighting part is when they restore the backup. Not always known to work. And then, upon a failure, you need the ability to detect your failure and then to act upon it. And you need to recover your infrastructure, and you need to recover your application on the other cloud. So there's two considerations when you're doing disaster recovery. First one of them is the recovery point objective. This is how far are you ready to go back in time in respect to your data when disaster happens, or how much data you're ready to lose. And this decision usually costs money. So if you want a very good recovery point objective, in seconds or minutes, that costs more. And you need to use technology like replication, or if you wait a little and lose a bit more data, you use asynchronous replication, or you can go into a backup restore mode when you're actually backupping your data and restoring them, and that you can go back even days back in time. On the other hand, you have how much time it takes to recover. What's your recovery point time, recovery time objective? So it could be from seconds to weeks, and you could have high availability, or you can have a hot site, and this also translates to how much you're ready to invest for your disaster recovery, and how long it will take you to be operational again following a disaster. So taking all this, what I want to show is what we want to have for OpenStack. And I'm going to do that using a demo trailer, and we'll be showing a bit of disaster recovery using a backup restore method. So that's quite a high PO. And we'll be demonstrating how you could use Heat to do orchestration and deploy workload in OpenStack. So I'm going to jump to this. So this is a very short demo showing what you could do. Hopefully it's going to work. So this is we'll be using a mock-up version of Horizon, where we actually added a disaster recovery panel, and we can see that we have a workload, and we'll try to install that because you're not seeing. Actually, I'm not seeing the entire screen.
Try F11.
Yeah. Right, that's probably wrong one. Also for that. It's good. Okay, that's better. Okay. Yeah. It's probably too big for the scale.
You got to change the resolution of your display.
Yeah, that would work when you run. Okay. Oh, sorry about that. So we can rerun that. And we can see that there is a disaster recovery tab. This is something that we added for this purpose of the demo. And this is actually a new screen where you could look at volumes and instances within tenant. You can select them for disaster recovery. And then after they're selected, you could click on the create point in time. So, so what's going to happen now is that you're going to create a recovery point in time for your system. It's going to look for all your configuration. For example, all the VM images that are in use by the virtual machines are going to be copied to the other cloud. If you have storage, this storage is going to be cloned and back up into a geo-replicated Swift. So you could have independent representation of your data, of your backup data for your persistent storage. And the last thing that's going to happen is that you're going to have a deployment description of how to redeploy workload in the other cloud, so you could redeploy that upon a disaster. And then a disaster happens, although this hasn't come to Tel Aviv lately.
There is quite a storm headed this weekend, but it's very tiny.
Yeah, I'm thinking it's maybe a little bit of flooding.
Yeah.
You know,
we'll be lucky if we get some snow, right?
We're not that lucky. So we're gonna switch to the recovery cloud, and we log again, and then we go to the disaster recovery panel. But now, first we can see that it's an empty cloud. There's nothing on the tenant. And then we're going to go to the recovery panel and just, click on the recovery button. And then we need to provide a prefix for it to use when redeploying the workload. And what we're going to be executing now is the OpenStack orchestration and use HIT to deploy the workload using the workload description that we created. And this is actually a standard OpenStack orchestration panel showing that we have a volume which is now in a restore state. So we are restoring the volume from Swift on the other end, on the other cloud. And when that volume will be restored and available to use in OpenStack, we will launch the virtual machine. And we can see that the volume is ready, so we're now deploying. Actually, we're saying HIT is deploying the virtual machine and running that. And now we can see that we have an environment that has a virtual machine and a volume attached to it. We're going to see that in a minute. So we have the VM instance, and we also have the attached storage. So I would look at that and say, well, this is what we want to have in OpenStack today. This is a mock-up that we have done, and that's what we're aiming for. So if I'm going to let my co-speaker, Ayal, continue with the talk.
Thank you, Ronen. So Ronen started with a general definition of what DR is, and then he jumped to a demo of what DR would look like from a user perspective. I would like to try to look under the hood a little bit, but first, a quick touch on what DR is in our eyes again. So, as Ronen said, basically we're talking about geo-independent cloud deployment. That would translate into I have two OpenStack setups on two remote sites. Okay, we differentiate that from high availability, and now we can start looking at the OpenStack services and see where they fall. So we have Nova cells and possibly regions is controversial whether it's high availability or disaster recovery, but those usually fall under high availability. We have Glance multi-locations, which again is under high availability. Swift Global Cluster already supports multi-regions and supports disaster recovery. And what I would like to focus on is Cinder volume replication. Cinder volume replication is a new capability that we're introducing in Icehouse. It will basically a user will be able to use it for both high availability if you have synchronous replication or within the LAN, and then with async replication you can go across and move into the realm of disaster recovery. Before that, again, we're talking about a user's workload. This is not about DR for your Cinder setup. This is not about DR for your Swift or Glance. We're talking about a user having, for example, a classic 3-tier application, wanting to be able to deploy the same application or recover on a remote site. Under the hood, there are a lot of things that need to happen to make that a reality. From a networking perspective, if I have my web app talking to my backend, which is talking to a data layer, then we need the same virtual network to apply in the remote site when we're recovering our instances. We need the images, we need the storage, okay, basically the data. We need security definition. So if I have a tenant in site A, we need to be able to have equivalent configuration on the remote site. There are a lot of things that need to happen in order to allow for DR to succeed. There is a lot of work to do. I'm not going to dive into all of it. I'm going to focus on one little thing. But if we treat all of this as a black box, then we have our workload description. Then we have a DR middleware which takes care of extracting all the metadata and data, replicating it across to the remote site. There we have the DR middleware that is responsible to deploy this on the remote site, and we can start up with our workload on the remote site. Now, mind you, there are a lot of complications that can happen. If I don't have a lot of money, I may want to downsize my instances when I move from the local site to the backup site. Depending on my recovery time objective, I may be just storing my data and I want to deploy everything on the fly when I start up versus having everything highly available on the remote site after disaster. So I'm going to focus only on Cinder replication. Basically the underlying assumption here is that I have continuous replication of my data. In order to recover on a remote site, I need to be able to have all my data available up to my RPO, right? So the time lag between what I have here and what I have here is my RPO. How will we do this? So first of all, the goal is to enable cloud administrators to provide data resiliency in a way that is transparent to the users. Okay, we don't want the end user to be aware of this. Our method is to enable Cinder to manage replication of volumes. We are defining two types of replications. Basically, either a storage array replication, so that means that I have two storage arrays that can replicate between them, and then Cinder will be able to reflect this and create volumes that are replicated, or hypervisor-assisted replication, which means I have, for example, KVM, which has two volumes attached at all times and makes sure to replicate the data between them. Before I proceed, any questions on this? Okay. So, what would this look like? The storage would, if we're talking about a storage array-based replication, normally what a storage admin would have to do today is set up a relationship between two storage arrays. You would still have to do this with storage replication in Cinder. Okay, so the storage admin would have to create a relationship between two storage arrays. The Cinder volume can then discover these relationships and based on them create replicated volumes. They need to expose basically two parameters, what the minimal RPO is and what the maximal RPO is. Okay, so if I as a user have a certain SLA I want my volume to adhere to, then I need to know that I'm able to create a volume that adheres to this SLA. So the Cinder volume driver will need to be able to report what these SLA parameters basically are. The way the user will consume this is not via RPO or understanding that there is replication underneath, but actually the cloud administrator will define a volume type. This is an arbitrary name. I can say my golden volume, and this will underlying or underneath the hood will be translated into a replicated volume on my IBM storage, for example. Cinder scheduler gets the definition of or the policy that the user wants this volume to adhere to, and chooses the best Cinder driver to use that can provide such a volume. Any questions on this? Okay. In Icehouse, so the road is long. In Icehouse, there will be some limitations to this capability. First of all, unfortunately, we're only going to support a single OpenStack Cinder deployment in Icehouse. So basically, that is not yet the DR that we would like to provide. And we're going to define two types of volume. We have the primary volume where data is written to, and the replicated volume we denote as the secondary volume.
Are you using self for incremental replication, or making only full replication all the time?
It's not, so replication is continuous replication. So you start with a sync of your data, and then you just go on replicating all the data that arrives. This is not a single point in time that you choose, okay, I want to replicate now.
Anyway, you can do it incrementally, right?
So the idea is that each driver could implement it in its own way. The replication framework does not control how you do the replication itself. It's a management plane function. So each driver, for example, like you get the example of Ceph, could implement this as fast as it could. Same for other storage or host-based replication solutions.
So I can give two examples for that. One is Gluster, which does continuous replication. Basically, all I/O that arrives immediately is replicated to the remote geo cluster. And the other, I don't know who here was in Hong Kong, but Nexenta presented a snapshot-based replication. Okay, so they would hide that underneath the scenes, under the hood, and they would define a quite long RPO, but then their replication would be take a snapshot, replicate the snapshot, then next time take another snapshot and just replicate the difference. So that's incremental, if I understand correctly.
It's a management play. How you will make sure with the application, from the application point of view, application management, it's your right time to make a replication.
That it's consistent.
For some application, for example, database, you need to stop the database before making an application.
Perfect, thank you. So, if it's snapshot based, okay, in Havana actually, we introduced a feature that is guest assisted snapshots. Basically, the ability to take a snapshot where the guest is aware, you have a guest agent running inside your instance, and if your guest agent has integration into VSS, then it can quiesce your Windows guest. If it has integration to your database, MySQL or whatever, it can quiesce your database. Then you take the snapshot, then you thaw basically your I/O, you make it resume the I/O, and you can go on. And then the snapshot that you take is not just crash consistent, but in fact it's application consistent. The level of consistency that you want depends on how far you're willing to go in order to ensure. Okay, but the mechanisms are there.
So this isn't that.
So again, this is Cinder exposing replication that it comes from the drivers. If the driver implements replication like Mizenta suggested based on snapshots, then you could do that. If it's continuous replication, then it probably will be crash consistent, and depending on whether you have a single volume or multiple volume, whether you can maintain a consistency.
And using another technique like reply logs.
Right. So we're not going into how the replication happens. Okay, that's the responsibility of either the underlying technology. If I have two EMC machines, they already know how to replicate between them, and they know how to keep crash consistent. What we're doing is exposing these capabilities, as Cinder does for many other capabilities that storage arrays have, like snapshots, like thin provisioning, etc.
And the framework just add the ability for you or anyone to write a driver that support this kind of application. So if you want to use log shipping or whatever mechanism, you can do it like that.
So basically, as I said, the road is long. There are lots of things to do. There are lots of places we can take this. Ronen promised beer, so IBM will be sponsoring that party for all the people who decide to join in. Thank you for picking that up, Ronen.
Yours on me as well.
What?
Yours on me as well.
There are various ways where in which you can join, participate, or just track and see what's going on. So we have a wiki on the OpenStack.org site. It's disaster recovery. The presentation will be available, but I think this is pretty easy to remember. We started a mailing list, so if you really want to be active, sign into the mailing list. If you want to know more about the volume replication, so there's the blueprint, and then there's an Etherpad with a lower level design. If you want to see the disaster recovery talk at the Ayal Summit, and if you want to read Red Hat blog on DR, so that's redhatstack.com. We blog there about our progress, so that's also a good way to get involved and see what's going on. More questions? Thank you very much.